In this tutorial, we will learn how to shoot using raycasts. Raycasts are invisible lines from point A to point B in the game world. The important point about raycasts is that this invisible line, or ray, that is cast into the scene can return information about game objects that have been hit by the ray. The game objects must have a collider attached to register a hit with the ray. When a hit is detected, the ray can tell us details about the game object and the hit itself, including a reference to the game object's transform, the length of the ray when it hits something, the point in the world where the hit happened, and more. For more information on rays, raycasts, and the raycast hit, please see the information linked below. In a shooting game like an FPS, we aim by looking around with the mouse or the right joystick on a gamepad. The target we want to hit is always directly in front of the center of the camera. When we click the fire button, we use a raycast from the center of the camera. This raycast creates an invisible line from the camera, which is the player's eye as far as the game is concerned, forward into the game world. If this ray collides with a game object, a hit is registered. This means whatever the player looks at directly, they can shoot. Here, we have a completed example of the scene that we are going to build. We have a first-person character controller from Unity's standard assets, and we have added a gun game object as a child. So when we rotate the camera using the mouse, the gun game object will rotate with the player and face the same direction as the camera. We've also added a UI canvas with a target reticle image, which is marked by this red reticle dot that we see here in the game view. Let's play our scene and test. As you can see, we can turn and look around. You can see in the scene view that we have a green line which is representing the direction that the player is aiming in. This is not the raycast. This is a visual representation of where the raycast will be that we have added to the scene using a visualizing and debugging tool. If we fire, we can hit the boxes and apply physics forces to them. And if we shoot them 3 times, they will be deactivated. If we look at the scene view while the player is firing, we can see 2 lines. The green line represents the direction that the player is aiming in from the center of the camera, marked by the red reticle dot. The pink line is the visible laser that we see in the game view, which is being rendered from the end of the gun to the point that the player hit with the raycast. Let's exit play mode, and we will walk through the steps necessary to set this up. If you have not yet downloaded and imported the asset package for this assignment, please click the link below to begin the download process. Once you have downloaded and imported the assets into a new empty project, open the folder called Let's Try Shooter. In the folder Scenes, you will see a folder called Completed Scenes, which holds this completed scene. In the root level of the Scenes folder, you will see a scene called Shooting with Raycasts. This is the version of the scene which has not been completed, and is the scene we will be working in. Double-click Shooting with Raycasts to open it. It is worth noting that both scenes are nearly identical and will look very similar to the eye. Please make sure that you are working in the shooting with raycast scene and not the scene called raycast shoot complete. The first thing that we'll do is create a new script which we will use for our gun. Select the Scripts folder, and from the Project View's Create menu, choose C# script. This creates a new script in the selected folder. We'll call this script Raycast Shoot. Let's add this script to our gun. Select the FPS controller and expand it. Expand the child object first-person character. Drag the Raycast Shoot script from the Scripts folder to the gun in the hierarchy. And select the gun. Now, let's double-click on the script to open it for editing. The first thing we'll do is delete the default comments. Next, we will declare a series of public variables. We will declare a public variable of the type int called gun damage. We will initialize it to 1. Next, we will declare a public variable of the type float called fire rate and initialize it to 0.25. Fire rate will control how often the player can fire their weapon. If the player has just fired, they will have to wait 0.25 seconds before they can fire again. We will declare a public float called weapon range and initialize that to 50. Weapon range determines how far our ray will be cast into the scene. Initializing it to 50 means that our weapon will have a range of 50 units. We will declare a public float called hit force and initialize it to 100. When our raycast intersects an object with a rigid body component attached, we will apply force to it, the amount of which will be defined by this variable. We will declare a public variable of the type transform called gunEnd. GunEnd will be an empty game object which will mark the position at the end of the gun at which our laser line will begin. We will declare a private variable of the type camera called FPSCam. We will declare a private variable of the type wait for seconds called shot duration. We will initialize shot duration with a new wait for seconds object which will have a duration of 0.07 seconds. We will use this variable shot duration to determine how long we want the laser to remain visible in the game view once the player has fired. The function controlling the display of the laser in the game will be a coroutine and needs a wait for seconds object to determine how long the laser will be drawn for. By declaring and caching the wait for seconds now, we will help optimize memory performance. We will declare a private variable of the type audio source called gunAudio. This will hold a reference to an audio source that we already have attached to our gun, which we will use to play our shooting sound effect when the player fires. We will declare a private variable of the type LineRenderer called laserLine. The LineRenderer takes an array of 2 or more points in 3D space and draws a straight line between each one in the game view. We will declare a private variable of the type float called nextFire. NextFire will hold the time at which the player will be allowed to fire again after firing. In Start, we will set up our component references to our LineRenderer, gun audio source, and our FPS cam camera. First, we will get and store a reference to our LineRenderer component in our variable laserline. Next, we will get and store a reference to our audio source in gun audio. Because our camera is not attached to our gun game object, which this script is attached to, we will use getComponentInParent to get and store a reference to our camera FPS cam. getComponentInParent will search first the game object that it is attached to, then each game object in its parent hierarchy, storing a reference to the first component of the specified type that it encounters. The core of our code will be written in the update function. Here, we will handle user input, check if the player can fire, and ultimately apply physics forces to any game object with a rigid body hit by the ray. In Update, we need to check if the player has pressed the fire button and if enough time has passed since they last fired. Each time the player fires, we need to track the current in-game time and then add it to the value of fire rate, our shot frequency public variable. We store this sum in our private variable called nextFire. This is why in our if statement we need to check if the value of the current game time has exceeded our shot frequency, meaning the player can fire once more. We will do this using an if statement to check if the fire 1 button is currently held down and time.time is greater than the time stored in our nextFire variable. If that if statement evaluates to true, then we will reset our next fire time by setting next fire to equal time.time plus fire rate. Now it's time to turn on and off our laser effect. We will do this using a coroutine. Let's declare a new private function that returns IEnumerator called shotEffect. In shotEffect, the first thing that we will do is play our gun audio source to play our shooting sound effect. Next, we will enable our LineRenderer laser line. Now, we want our coroutine to wait, in this case for 0.07 seconds, before it turns our laser line back off. We will tell our coroutine to yield and return our wait for seconds variable shot duration, which will cause our coroutine to wait for 0.07 seconds. Once it's done waiting, we will disable our laser line. With our coroutine complete, we want to start it whenever the player fires. Back in Update, we'll call start coroutine and specify shotEffect. Now, the thing that we need is an origin point for our ray, so we will declare a new variable of the type vector3 called rayOrigin. In order for the player to be able to aim accurately, we want this point to always be at the center of our camera. The way we will achieve this is using viewport to world point. In this case, we've passed in a new vector3, which is set to 0.5 on the x-axis, 0.5 on the y-axis, and 0 on the z or z-axis. What this does is take a position relative to the camera and converts it to a point in world space. To understand this better, let's return to Unity. First, to show the gizmo better in the white environment, we will turn off the main directional light temporarily. Next, highlight the first-person character game object which holds the camera. Now, we can see the camera's view frustum. This shape is a four-sided cone or pyramid with the tip cut off. The near end of it is the camera's near clip plane. The larger rectangle farther away is the far clip plane. Only game objects within the camera's frustum are rendered. This frustum sets the boundaries for our camera's viewport. Viewport to world point uses viewport space. This space is normalized and relative to the camera. The bottom left of the viewport is defined as 0, 0, and the top right is defined as 1, 1. By specifying a value of 0.5 along the x-axis and 0.5 along the y-axis, we are getting a point at the exact center of our camera's viewport. Passing 0 for the z or z-axis means that the position will be 0 units away from the camera, or exactly where the player's position is. With that done, let's turn the main directional light back on and continue. Returning to our script editor, we now need to declare a variable to hold the information returned from our ray if it hits a game object with a collider attached. This variable will be of the type raycast hit called hit. Now, we need to determine start and end positions for our laser line when the player fires. The first thing we need to do is to establish the initial position of the line. In order to draw a line with a LineRenderer, we need to specify at least 2 points for it to draw between. Let's set the first point, or position 0, to gunEnd.position. Remember, gunEnd is the empty game object that we will attach to the end of our gun in the scene. This empty game object will give us the current position in world space for the end of our gun. We can safely set this here, as every time the player fires, we want to start the LineRenderer at the end of the gun. Next, we will use physics.raycast to cast our ray. We will use the results of this raycast for a number of things. The first thing we will use it for is to determine where the end point of our laser line will be. Later, we will also use the results of this raycast to apply physics forces to the game object that it intersected, and to deal damage to it if it has a damage script attached. Physics.raycast returns a Boolean, meaning that if it hits something, it will evaluate to true. By placing it in our if statement, this means that the code that follows will only be executed if our raycast hits something. The first parameter that we will pass in when casting our ray is ray origin. This will be the point in our world where our ray will begin. In this case, the center of our camera's viewport, stored in ray origin. The direction which we will cast our ray in will be the forward direction of our camera FPS cam. We will store additional information about the object that we hit, including its rigid body, collider, and surface normal, in our raycast hit using the out keyword. Using the out keyword allows us to store additional information from a function in addition to its return type. Finally, we will pass in weapon range, which is the distance over which we want to cast our ray, in this case, 50 units. There are two possible positions for the end of our laser. The first is the position of whatever we hit with our raycast, but it's possible that if we fire into the sky, our raycast will hit nothing, and we need to account for that behavior as well. In the case where we hit something with our raycast, we will set the second position of our line to hit.point. In the case where our raycast has not intersected with anything, and therefore our first if statement returns false, we'll use an else to set the end of our line 50 units away from ray origin in the forward direction of our camera. Let's save our script and return to Unity. Now, let's set up our laser, which will make our shots visible in the game view. Highlight the gun game object and choose Game Object, Create Empty Child. In the inspector, rename this new child object to Gun End. Let's also apply a label to our gun end so that we can see it easily in the scene view. Now, let's position it in front of the barrel of our gun. Select the gun end game object, and in its transform component, set the position on the x-axis to 0.36. Set the position on the y-axis to negative 0.18, and the position on the z or z-axis to 1. This will position it directly in front of our gun barrel. To make our shots visible in the game, we will use a LineRenderer component. The LineRenderer will draw a line from the position of gun end to the position that the player aimed at using our invisible raycast. Highlight the gun game object and click Add Component, Effects, LineRenderer. Now we need to assign the gun end variable of our raycast shoot script. Drag the gun end game object to the gun end field of raycast shoot. Now let's tweak the parameters for our LineRenderer to make the line a little bit narrower. We'll set the start and end width to 0.05. It's worth noting that we have not assigned a material to the LineRenderer, and this is why it will render pink. If we want to change the color of the rendered line, simply drag a material to the element 0 slot in the materials array. The last thing we need to do before we are done tweaking our LineRenderer component is to disable it. Click the Enabled checkbox and make sure the component is disabled. The LineRenderer is enabled by our raycast shoot script when the player fires the weapon, so it should be disabled by default. When working with raycasts, it can be useful to visualize them in the scene view. We are going to write a simple helper script which will allow us to visualize our raycasts in the scene view. It's worth noting that this script is a development tool and should be removed before creating the final build of your game. Let's start by creating a new C# script called rayviewer. Highlight the scripts folder and select Assets, Create, C# Script. Name the new script rayviewer. Next, drag rayviewer onto the gun game object in the hierarchy. Select the gun and double-click rayviewer to open it for editing. Rayviewer will duplicate some of the functionality of Raycast Shoot because its purpose is similar. Instead, however, of casting a ray, we will simply be drawing a line to show where our ray is going in the scene view. The first thing we'll do is delete the default comments. Next, we will declare a public variable of the type float called weapon range and initialize it to 50. This will determine how far our line will travel into the scene. And we will declare a private variable of the type camera called FPS cam. In start, we will use getComponentInParent to store a reference to our camera in FPS cam. In update, first we will calculate the origin point of our line, and then we will draw it using debug.drawRay. To calculate the origin point for the line that we will draw with debug.drawRay, we will use much of the same code we used to calculate the origin of our ray. Again, we will use viewport to world point, passing in 0.5, 0.50 to draw the line from the center of FPS cam. Next, we will call debug.drawRay. Debug.drawRay allows us to draw a line which will help us to visualize where our ray is being cast in the scene view. The first parameter that we will pass into debug.drawRay is line origin. This will specify where we want the line to begin being drawn. Next, we will pass in fpscam.transform.forward multiplied by weapon range. fpscam.transform.forward specifies the direction we want our line to be drawn in this case, away from the camera. Multiplying this by weapon range specifies the distance over which we want our line to be drawn. Finally, we will specify a color for the line to be drawn, in this case, color.green. For more information on debug.drawRay, please see the information linked below. Let's save our script and return to Unity. Let's play our scene and test. Let's exit play mode. Now we can draw the visual effect for our shooting, but we can't yet affect the objects in the game. Before we return to our script, let's take a look at the object that we want to interact with. Expand the Environment game object in the hierarchy and select the Target Box game object. In the inspector, we can see that the target box object has a script attached to it called shootable box. Shootable box has a public variable called current health, which is set to 3. Double-click the script in the script field of shootable box to open it for editing. Shootable box is a simple health script. In it, we have a public integer called current health, which is initialized to 3. We have a single public function which returns void called damage. Damage takes a parameter of the type int called damage amount. When the damage function is called, we will subtract damage amount from current health. Next, we will check if the current health is less than or equal to 0, and if it is, we will call GameObject.setActive false to deactivate the game object that this script is attached to. Let's return to our raycast shoot script. In the if statement for our raycast, we are going to check if there is a shootable box object attached to the collider that our raycast hit. If it is, we will call that object's damage function and pass in our variable gun damage. First, let's declare a variable of the type shootable box called health. We'll set this to equal hit.collider.getComponentShootableBox. What this means is that if there is a shootable box component attached to the game object that we hit, it will be stored in our variable health. Next, we will check if health is not equal to null, meaning there was a shootable box component attached to the thing we hit. If this statement evaluates to true, we will call the damage function of health and pass in gun damage as a parameter. Gun damage was the first public integer we declared in this script and is currently equal to 1. Next, we will check if there is a rigid body component attached to the game object we hit with our raycast. If there is, we will add force to it to move it around. We will do this using the function addForce. We will add force to the rigid body of the object we hit, and we will pass in negative hit.normal times hit force. Hit.normal is the direction away from the surface we hit. By using negative hit.normal, we can add force to the target box in a direction away from the surface that was hit. Multiplying it by hit force allows us to control how much force should be added when we shoot the object. With that done, let's save our script and return to Unity to test. As we can see, our target box game objects already have a rigid body component attached, so they should be ready to shoot. Let's give it a try. Play the scene. So our basics are working. Let's exit play mode. As you may have noticed though, it's still a little bit difficult to aim. Let's add the final component, which will be our UI for our reticle. The reticle UI is very simple. It's a small red UI image in the center of the screen. To add this, let's go to Game Object, UI, Image. Let's switch our scene view into 2D mode and push the F key to frame selected on our image. If we zoom out with our mouse wheel, we can see we have a white image in the lower left-hand corner of our screen. The first thing we'll do is change the image's color. With the image selected, click on the color field in the image component. We'll drag the color swatch all the way to the upper right corner to make the image red. Now, let's anchor our image to the center of the screen. Click on the Anchor presets and hold down the Alt or Option key and click on the Center preset. Now, our reticle is in the middle of our screen, but it's still too big. In the Rect transform, click on the Width field and set it to 5. Next, click on the Height field and set that to 5 as well. Now, we can play our scene and test again. As we can see, we have our reticle anchored in the center of our screen, and we can aim and fire much more easily. That's the basics for shooting with raycasts. If you want more game mechanic focused tutorials, please check out our other Let's Try tutorial assignments.